In this example, we have that you wish to determine the distance across a lake for which a bridge is to be built. The bridge is to span from point A to point B across the lake, and to measure the distance, you find a point of reference R away from both points A and B. I take a quick second to draw that. I have a lake over here, and I have a bridge that I want to make that goes over this lake from points A to B. To survey and reference this, I have a point R that is away from both points that I'm going to use to try to measure the distance across the lake. We are told that the distance from point R to point A is 245 meters. So this is 245 meters. And the distance from point R to point B is 340. So this is 340 over here. We are then also told that angle measure RAB is 52 degrees. And we are asked to find the length of the bridge rounded to the nearest meter. When it says angle measure RAB, what that means is that we're talking about the angle measure that is formed by the corner from R to point A to point B. So that would be from R to point A to point B. The angle measure formed in that corner would refer to the angle measure at point A. This is 52 degrees. All right, in this example, we are trying to find the length across the bridge. So we're trying to find this value that I'll designate as X, that is across from point R. We can try to use law of sines to try to work with this because we know one angle measure and a side across. As long as we know that, then we can set up a full ratio, set that up equal to another partially solved ratio. Solve for whatever value is missing. Unfortunately, though, even though we want to solve for X, we cannot directly set that up because we do not currently know the angle measure R, nor do we have a quick way of solving that. So we're going to need to go through and solve what we can and hopefully get to a point where we can solve for X. And what I can solve for right now, because I know the side length of 245, I should be able to solve for the angle measure that is at point B that I am missing currently. I'm going to refer to that angle measure at point B. I'll just call that beta. And if I want to solve for that, I'll set up a ratio of law of sines with sine of beta over the side length that is across from beta, which is 245 meters. If I want to solve for beta, I want to set this up equal to a ratio that is completely filled out. So that is where A comes in, because we know sine of the angle measure at point A is 52 degrees. And the side length across from 52 degrees, we know is 340 meters. We should be able to solve for beta there. Now you may notice that the triangle that we are working with here, based on the information provided, is one where we have a side length, and an angle measure. This is what is called a SSA triangle. These are the ones that can possibly cause ambiguous cases. We are going to have to deal with that. So let's solve for beta, knowing that we could possibly have a secondary set of solutions. If we solve for beta by multiplying both sides by 245 and then taking arc sine of both sides, we should get beta is equal to arc sine of 245 times sine of 52 degrees divided by 340. So I multiplied the 245 over to the left or to the right, and then took arc sine of both sides. Here then we can approximate our value for beta, and we'll use a calculator for that purpose. Pulling up a calculator here, be careful that we are in degree mode since we will be using sine of 52 degrees. We'll take inverse sine of 245 times sine of 52 degrees divided by 340. That gives us about 34 point to 2 decimal places 60 degrees, or 6. So 34.6 degrees. Now that I know that, I should be able to calculate the third angle measure, the other one that is missing, which is at R. I'll just call that angle measure R. I should be able to find angle measure R, as that would be 180 degrees minus the two now known angle measures of 52 and 34.6. So 180 minus 52 minus 34.6 gives me about 93.4. Now that I have angle measure R, the only missing side length is the value that I wanted at the beginning, the distance across the lake for this bridge. That is what is designated here as X, which is the side length across from 93.4. So I can now use law of sine since I have the angle measure across. If I want to solve for X, I will set X to be on top of a fraction that is over sine of 93.4 degrees. And I can set that equal to a fraction. In this case, I'll use the original values that I had for 340 meters and 52 degrees, the angle measure and side length that are across from each other. Because I decided to set X, the side length, on top, I'll put 340 on top of the next fraction, divided by sine of the angle measure across from 340. If you now multiply both sides by sine of 93.4, we will get X is equal to 340 times sine of 93.4 divided by sine of 52. That we now should be able to approximate to find the length of this bridge. We'll round that to the nearest meter. So let's pull up a calculator here. If I want to try to approximate this, we will do 340 sine of 93.4 divided by sine of 52. Again, please be sure that you are in degree mode when putting in a degree measure. And we get 430.7, or to the nearest meter would be approximately 431 meters. Now, I said earlier that there is a possibility of this having another solution. That is because we're dealing with a side-side angle triangle, and we are working with a possibly ambiguous case. Well, if there is a second solution, the second solution would have a different angle measure for beta. Instead of what we have currently, it would be the supplement of beta, so 180 minus beta, or 180 minus 34.6. We do that, that would give us an angle measure of 145.4 degrees. That would be the other possibility for beta. And since we now know the other possibility for beta, we should also be able to solve for the other possibility for r. So I'll call that r prime. Well, we solved r by earlier doing 180 minus my two known angle measures. 180 minus now the two known angle measures would be 52 and 145.4. Well, now that's going to be a problem. If you do 180 degrees minus 52 minus 145.4, you're going to get an angle measure that is negative. What you're going to get here should be negative 17.4 degrees. Looking at that, then, I now know that there could not be a second solution because in a realistic triangle describing these measures, we should not be able to have a negative angle measure. So there is not a second solution from this. Even though it is a side-side angle triangle, there is only the one answer of 431 meters for the length of the bridge. One other way that you can tell a little bit earlier if there is going to be a second solution, I would recommend look at the angle measure that is originally provided to you in your SSA triangle. In this case, that is our 52 degrees. Then look at the angle measure that you solve for first, our value of beta in this case, 34.6. If the angle measure that you solve for, the first one you solve for, is larger than the angle measure that you are provided, then there is another possibility. There will be another set of solutions. But, as shown here, if the angle measure that we solve for first for beta is smaller than the angle measure that you are provided, then you will only have the one possibility, which is what we had here.